You're the one that can see it.
I can't see it.
Hello.
Hello?
Hello.
Oh, hey. Hey, Lily, how you doing?
Peachy Keen, Jelly Bean. How about yourself?
Good. Peachy Keen, I like it.
I would have called you earlier, Lily, but I just got back. I thought.
Oh no, you have perfect timing. I just took Mr. Pickles out and just got back in, and so you have exquisite timing, Neil. Don't worry about it.
Well, I was. Dave obviously did not get your email and put it on the list, so what a bastard.
For that.
I am.
Oh, really?
Welcome to the May 15th edition of the Electric View. I'm Neil Thompson. Today we have Heather, David, Edwin, Terrence, Buddy, Jim, Lilly, and Richard. We will be discussing the sun's electrical circuitry, the nature of plasma, and force-free aligned currents. Don't forget to like and subscribe.
I want to get back to what we were just talking about, and Ito and Jim were talking about this balance point, which I'm super interested in, by the way.
The balance point, okay. Go on.
So, Jim, do you care to pick up where we started and fill in these latecomers a little bit?
Just this article on the global electrostatic charge of stars, the most important part that they figured out, this was, again, back in the 20s, is that at the sun's surface, and the gravitational forces are on the same order of magnitude as the electric forces. The mainstream idea here is backwards of that, because they know that gravity matters. So this article was reminding them that the electrostatic forces become on the same scale as gravity. But for people in the EU community, this article should be a reminder of the opposite. That since we know that electrostatic forces are important, this should remind us that at the sun's surface, gravity is as weak a force as it is. At the sun's surface, it becomes as strong as, on the same order of magnitude as the electrostatic forces. So that's the part that we need to keep in mind, is that you can't ignore gravity at the sun's surface. As a matter of fact, that surface, you can see that is the point, the balance point, and that doesn't come from any crazy theory. We know what the mass. Forget what gravity is. We know that the mass of the sun, according to the gravitational pull, we can calculate what it is on the sun's surface.
Yeah,
and that's where you can see that how strong gravity is compared to these electric forces, and that's what's missing. And like Sapphire doesn't deal anything with that, but that's.
May I ask a question?
Sure.
So gravity is the weaker force, correct? I had read somewhere that electromagnetism is 1,000 trillion times stronger than the gravitational pull. So
right.
if electromagnetism is 1,000 trillion times stronger than a gravitational pull, why do people focus so much on the gravitational force rather than the electromagnetic force?
Well, actually, that's not exactly true. It is that much. Like if you look at, for example, the formula for gravity, and you recognize that it is the same formula for the Coulomb's law, so they have the same exact r squared radius thing, but the only difference is the value of K for coulombs and the value of the constant, the Coulomb's constant, and big G, as they call it, the gravitational constant. They are indeed that far apart, like billions, billion, like really far apart. However, that being said, the amount of charge will dictate the force involved here, Q1 and Q2, so to speak, and in mass is M1, M2. We know that the mass of the Earth is quite high. So, and I think we just lost Ito somehow. But But Jim, you were, I just read in that paper there that they say that it is 918 times higher for the Coulomb force, which I really don't know how they measure that because we really don't have a Langmuir probe, but I'm sure they did some calculations or something.
Yeah, it just comes from the calculations on how strong gravity is at the sun's surface. You can calculate what the force is on either electron at that radius or a proton at that radius. But then since more massive protons should sink deeper in any ball of plasma, if there's a gravitational field, the more massive protons should sink more deeply into it than the electrons.
Why is that? Do they know? Maybe I don't understand. Then please explain.
Well, that's assuming the sun is plasma, which...
No, I mean to the effect that the proton would sink deeper than the electron. Why would that be the case?
See, that's where that is really really simple equations of where you use gravity and even though just simple electrostatics and simple gravitational forces. See, we're taught. That's the first mistake we learn in school in physics, even in a high school physics class. You learn about gravity probably first in like mechanics is usually like first semester stuff. And then you jump to electrostatics and you're taught that if electrostatics are involved at all, then you should ignore gravity, and they're never put together. But the most important thing to consider is that no matter how lopsided the two forces are, there is going to be some point where they balance, and that's the key that's missing. That's what this whole article on the sun's surface is about. But that's something that's even missed in that's something that's missed in EU. The mainstream obviously forgets about electrostatics. But in EU, we tend to forget about gravity because gravity is 10 to the 37 or 38 magnitude smaller. But that ignores the fact that somewhere out there, in this case, the sun, the surface of the sun, gravitational forces, as weak as that force is, it becomes as strong as electrostatic forces. And that's where, to me, all the interesting things in the universe out there, that's where they exist. That cutoff that isn't talked about.
Right on that boundary. Right.
Yeah, and it's something you're not going to play around with in the lab because even if you have a single charge particle, you're not going to get a mass, 10 to the 37 times that,
Well,
True.
Wouldn't there be a place as you go down in there where you can get that proportion experimentally? I mean, the one thing that you say is it's not only true for the sun, it's true for all the planets as well, right?
Yeah, the same circuit exists for sure.
No. Wait. The proportion, this balance between gravity and the electrostatics, right?
Yeah, but planets would probably not be big enough. That's why stars need to be big enough to burn.
No, Jim, would you? I mean, I think I've heard you say this, but would you verify that I'm reading it right?
Yeah, well, I think Ito's comment is right though that if an object like the moon isn't going to have enough mass to tear the plasma, tear neutral matter apart at any rate, it could sit on the moon's surface, and you're still going to have, you're not going to tear apart your neutral matter into protons and electrons. But at the sun, the gravitational force is that strong. So
okay,
that is a different.
I would interject something if I may, and I think maybe that's what David is alluding to. What I think is on planets, the pressure could become strong enough, that equilibrium point, the similar equilibrium point, to maybe cause fusion processes, right?
Yeah, I can envision that. In fact,
combined with some other factors like a telluric current that's running through it.
Sure. I mean, concentration. I mean, that's one of the benefits of plasma itself is that it filaments and becomes concentrated, and you can get higher electromagnetic energy in certain spots than others because of that filamentation. And you're not wrong, by the way, Jim, that there's a point, and on any, like just on the Earth, it's like 500,000 volts. On the sun, it's supposed to be billions of volts. But wherever there is a voltage difference, that is where, quote unquote, as Dave puts it, well, that's where crap gets done. There's stuff happening at that point. No matter what, you have a voltage difference, you have a resistance, stuff will occur. You'll have weather, you'll have heat, that sort of thing. But you're right that taking into account the possibility of gravity at those locations is very interesting. Obviously, and then it would imply that larger stars, this would become easier even in certain places. It might occur slightly.
Sorry.
Can I just ask a question real quick about or throw in the idea of a neutron star, which is very very small but has huge gravity. Can we expand about how that falls in relation to this?
I think that's if I'm in standard EU theory, that's mostly considered a joke. I don't want to say it that way, but it's not real.
You do want to say it that way.
Well, yeah, okay, I did, but it's not. You can't have an atom get that big, and I'm pretty sure that Edwin, because that's all it is. A bunch of neutrons together would be an atom. It would be, but you can't have a 12-kilometer across atom. And this is needed to basically get to the black hole. So it basically becomes it's because of a pulsar. Basically, the reason they think that a neutron star needed to exist in the first place is because they found a pulsar that was spinning at 36,000 times a second. And no material can hold together spinning that fast. It will fly to pieces. I mean, the rotation speed alone on the surface if the Earth was spinning that fast, everything on it would just go flying, like there'd be nothing we could do to stop that. But, and so that's why they had to invent the neutron star. I think that it is an invention basically of Earthlings. It doesn't exist in real life. That's my opinion.
I agree.
I think.
But see, that's again, that article, that's what they were saying, is that the mainstream themselves, somehow after the 1920s, there was no mention of that electric field idea. But
okay.
If they would have kept that in mind the whole time, you can't get a neutron star because of that. Because you can't have neutral material inside that radius. That the whole idea is what they thought is if charged matter, if anything, should get pulled together into neutral matter and then it falls, then you only have gravity beyond that point, and that's how you argue for the neutron star. But in fact, charge gets torn apart by the differential pull. Once the differential pull between a proton and an electron in a gravitational field becomes stronger than the attractive force between them, you don't get a combination into neutral matter which falls into the black hole and neutron star. You get charge segregation and then repulsive forces for the first time. That's what they're ignoring. So what it means is,
I hear you.
If you have a shell of plasma where there's like more positive charge on the inside and then more negative on the outside, and you add matter to it, it should only expand in radius. You should now have charge pulled apart and then an even larger sphere of basically you should get hollow spheres, and that's what some in the EU, I think Wal was saying for the sun. He's been saying that for a long time, that is the surface of the sun is pretty much hollow. There should be nothing inside of it. But that's what we see in these shells of matter in space too. Anything from planetary nebula, and you don't get matter forming that way inside. You have a limit then to what's the only matter you could have inside that is matter that's without a strong enough gravitational field to pull the charge apart.
And this is going, of course, with the plasma idea of the sun. If there's if we go, and I'm just spitballing here, if we go with The Electric Sky, Don Scott's book, and we recognize that that pinch spheres, basically just like in Vemosat Laboratories by C.J. Ransom or other, basically just making little balls, hematite balls or whatever, larger and larger, you get concretions, larger and larger, you get moons, larger and larger planets, larger and larger stars. That's the starting point, the pinch that created these spheres, but it's not the end result as we have been discussing. That's almost a immature way of seeing stars, because we're seeing now, EU-wise, because we're seeing now from your work, just talking here, and of course what Edwin was talking about before, that we have to take into account not only electrostatic repulsion and gravity effects, and see where these come in and how they interact and where the balance points are, and the fusion processes that are endothermic or exothermic, as Edwin has said. Now, so I can envision all this, but I see a potential here where the expansion from the surface basically being a separation, which is creating the height of these of the anode tufts. This is and the thickness of the double layer, the thickness of the sun's atmosphere, so to speak. I can envision this also as being a potential way of looking at that, because if, as you said, the protons sink in and the surface therefore becomes electron based or negative, basically, and the core positive, then there will be another layer that has to be outside of the surface of the sun. If the sun has a surface, a solid surface, then outside of that there must be an opposite to this internal force, because otherwise they would slam together. So you need to have this. It would immediately attract plasma to hover around it, just like the ionosphere hovers around the Earth. These are, this is the layering of plasma, the idea that I'm getting across here. What do you think of that? I'm basically what I'm saying. And here comes Richard. That was directed mostly to you, Jim, by the way.
I think I think we're on basically the same page. What?
Oh yeah, I'm going with your facts. I'm trying to interpret them though, because there's different modes of thought. I mean, thinking that the whole planet expands. I recognize that there could be a hollow area to the sun, just as much as I think that there's a hollow area to the Earth, and to probably every planet with a magnetic field likely has a hollow inside somehow, and which would make sense if 40% of concretions are hollow and 40% of these things are hollow that we find in the lab, then it should also, if they're made by the same process, infer that 40% of planets and moons should be hollow. Just, if they're made by the same process. But I'm basically alluding to the possibility that's not actually the planet expanding, just this potential, and then the atmosphere, because if there's a solid surface, but we're basically working on two separate theories, whether or not it's a gaseous body, as Wal might say, or is it solid?
But this is the concretion idea is really kind of compelling to me, and it's like I'm interested in Ido, like your ideas with this, what you were discussing, starting to hint about. Is there any way that you could kind of like maybe illustrate that a little further, or comfortable with that? Is he still here? Ido's not here.
He exploded. Why don't we welcome Richard? Hi, Richard.
Richard. Hey, Richard. How you doing?
We're talking about stars.
Hey, I'm sorry, I was shopping and then got back, and then anyway, I'm late. But anyway, hope I didn't miss too much.
We're all late. Well, I'm late, or I was. So
I was right on time.
Of course you were, and pointing it out too.
Absolutely.
Do you want a cookie? Is that what you're saying?
I do want a cookie.
So you were talking about hollow planets and stuff. Is that related to Wal's theory of gravity?
Actually, we were talking about gravity. Jim had pointed out that there is a layer, or there's a balance point, and that modern astronomers had forgotten and dismissed electricity and the voltage or the Coulomb charge of the sun after 1920, and but he was warning us that we should take this into consideration because as EU proponents, we should not forget that on a body as large as the sun, the power of gravity can be extreme, and it can have an effect on the formation of matter, neutral or otherwise. If I'm not mistaken, Jim, that's in a nutshell.
Right. Yeah. Just think of just.
This paper is something that Jim quotes quite a bit, and it's discussing this balance point. So.
Yeah, I mean, I think that should be like really mandatory reading for anyone in EU, just like it should be for the mainstream, and that was the point of the article. But it should be mandatory reading for. Actually, in the Thunderbolts forum, that thing came up quite a bit, and people realized the significance of. Of that article.
I like how it says it's 918 times stronger. I would always assume, and this is probably an error now, but I figured that the effect of Lenz's law and what would we call the skin effect had a lot to do with the negative surface of the sun, mostly because there's a vibrating charge that's going through. We know that it's not stable. Basically, the charge going through the sun is not. The current that's flowing into the sun is not even. It is, full of ups and downs, as anyone who studies space weather might be able to indicate. So this would say to me then if you'd have to take that skin effect or the Lenz's law into effect to understand necessarily that it's going to push positive charges away from that surface, just like it does on a high speed transmission line, but. Then you're giving a different mechanism in here, which I think is very interesting because I didn't consider this just straight electrostatics.
That article said at the beginning there that it's because of the different masses that the protons. It's more proton rich near the surface and electron rich further out, but. My question there, is that something they've measured? I mean, it's somehow verified?
That's the first one I said, too. I said, how did they measure this?
Is it just their theory? Because, I mean, in the EU model, there's a current flowing into the sun, and a current is positive ions moving toward the sun. So there's no mystery from the EU perspective.
Well, yeah,
Is there a preponderance of flow through either the top pole, the north pole, or the south pole that creates the sun to be a dielectric? Like, is there one that's a stronger current?
Between the north and the south?
Yeah.
Well, those are both currents coming in. I mean, one is not a continuation of the other. And the one that's stronger determines what the polarity of the magnetic field. It's like the magnetic field reverses, every 11 years or something?
Yeah.
And that's because the relative strength of the two incoming currents shifts.
I can see that as a tug on the heliopause itself as the currents are coming, because the same effect that would be happening on the surface of the sun is technically happening at the heliopause as well, because that's a techno virtual surface. So there's going to be flow that's going to be sort of mangling the shape of that, for lack of a better term, and that will push positive charges closer or away from the sun, therefore create this imbalance. I could envision, sitting there.
Well, I mean, all those, what do they call them, speculate, whatever, those tornadoes going into the sun, those are all currents of positive charge going into the sun. So.
But they're coming out of it and going back into it too.
Yeah, most of it through the sunspots. That's where it, ironically in the Thunderbolts forum, there's a few very intelligent people there that are arguing they should really be given presentations in the main conferences, but they've got a little bit of the circuit worked out, and the whole idea of what should happen, though, is that if you have charge coming in from the sun, the mistake is thinking that it flows in most of the current flows in the solar wind or just radially everywhere uniformly at the sun. But no, you should have Birkeland currents forming with this charge. And what you do see at sunspots is where most of the current is actually flowing. It's through the sunspots. It's not falling. It's not radial current all around the sun. It's coming through in small scale Birkeland currents. And all you have to do to know that is look in what's happening on a smaller scale on the Earth's surface. Like, we know that there's lightning discharges where all the main current is, right? There might be current flowing into the poles, but we know that electric lightning discharges go all the way to the sun. That was one of the points made by guys like Wal from way back. We just don't see it. It's might be visible between us and the clouds, and then it changes to these other frequencies. But that sunspots, just like lightning strikes, are really intense sources of current, and that's why.
Yes, in fact,
they're missing though. Like in the solar wind, those aren't the main currents, and that's why you're going to get all the puzzles that are still there in the EU material. Like, are the electrons streaming towards or away from the sun? We see both, and like if you're looking at that as the main current, what's in the solar wind, you're going to be thrown way off because most of the current and even the mainstream, what they see that's really important in sunspots is they can see material coming up and going down into different radial velocities of material there. So we know that there's a lot of material flowing up and down through the sunspots. It's just in the mainstream view, it's always net neutral material, so it's not current flow, but they see all this material flowing up and down through there. So that is where the main current is, and that's
you're absolutely not wrong in the sense that this is exactly how it is described by Donald Scott in The Collapse of the Double Layer. Basically, the double layer, just like the anode, just like we were talking about before about the fluorescent tube, a lot of the charges will pull right up to the anode and they'll just hover right above it. This gives us our corona, and this is where your double layer occurs. But when that breaks down, a massive amount of ions are just flowing right on out. They're just go, and they're being projected right off the sun, and this is where your sunspots are. So you're absolutely right. I mean, there's nothing wrong with theory on that.
What types of currents are we riding on powering the sun? And where are these currents coming from?
that is the infinite question, isn't it?
Well, the EU model is that they're coming from the center of the galaxy. Currents are going out all over the spiral arms, creating stars and powering stars.
And the Earth is sitting in a current that is coming out from that orange strip along the middle of the sun that you're seeing. It usually doesn't go above 30, and it doesn't go below 30 degrees. It usually hovers right in there, just like on Earth. This is where Thunderstorm Alley and Tornado Alley and all the stuff happens. They connect to the neutral point along the equator, or along the ecliptic, and voila. This is just like a galaxy, and this is the same, basically the homopolar motor effect. That's why the currents, for lack of a better term, go in the poles and out along the ecliptic, out along the middle, and so it creates that tippy top look.
To go all along the surface, to be distributed efficiently, to have efficient charge distribution through electrical storms and conduits along the Earth's surface, like a Torella.
Well, yeah, and it's the balance point, the magnetic neutral point, just like the rings of Saturn float right there. They float there because if they go up higher, they're going to be a load on the magnetic circuit. If they go down lower, they're a magnetic load on the circuit. So if they stay in the middle, they are neutral and they can hover there without issue.
Well, they experience, if they're off the elliptic or whatever, if they're off that plane and they experience a force pushing them back to the plane.
Basically, yes. And so do planets, I assume. Because that's what we want to go back down there.
And so, like in the the thing with Bessel functions that Don Scott did, it's the fact that the Earth's the sun's magnetic field is neutral along the equatorial plane, and so the bigger current, the outside current, is able to exert a force of the spacing of the planets.
And that's yes.
Well,
what I don't understand about. Oh, never mind. Go ahead.
I have a weird question. If the fields or the circuits and currents that are powering the sun are variant and they change, it's weird how throughout the linkage of the solar system, the vortices on the poles of the gaseous giants seem to stay the same for their vorticular shape, whether it be the hexagon or the octagon vortex, and they're, it's like it's refined. And then another question I had, well, that was just kind of like a comment, but a question that I had was how rapidly can some of the rings form on Saturn or the other planets that have rings? How rapidly do they form? Like, I heard it earlier that sometimes, like within 5 minutes, there could be new ring systems. I don't know if anybody knows anything about that.
Actually, that's news to me. I do know that the material is being shaved off of some of they're called shepherd moons. They think that they're gravitationally controlling the rings, but I don't think that's the case. I think that they're being etched. Materials being removed from these moons. Because also the moons of planets, besides our moon, mostly flow on this elliptic as well. They want to stay on that exact same plane. Our moon's very large, and it is argued, if we want to talk about something interesting, it is argued that in the past we did have rings, just like Saturn, and that they were disrupted when the moon came along, and that they were destroyed, because obviously the moon's gravity would totally mess that right up.
You mean when the moon was built?
When the moon was built. No, I think according to a lot of Saturnians, when we moved Saturnians, like as if it's an alien or something. No, the Saturnian theorist is that that we had moved, the planet had moved and caught up with another planet. The Earth had moved, and caught up with another planet, which was the moon, and we started orbiting each other because the moon really kind of orbits the sun, and we just spin around each other. It's a very weird situation, unlike most other moons. Actually, all other moons in the solar system. It's a very weird situation.
Did we discover if there's any vortexes on the South Pole or the North Pole of the Sun yet? Or if there's any images or pictures of that?
I don't think we were ever brave enough to actually stick a satellite into that current. Not yet, anyway. It's also very hard to do, like, how do you keep it orbiting there? Because, it's the sun, and it's not... It's going to be a very difficult thing to do, to make a polar solar orbit. It's hard enough to do one on the Earth. So,
well, there have been probes in the polar region of the sun.
Really? Okay, I did not even know that.
Reported on Space News. Yeah.
Okay, cool. I'm not behind the times.
They verified vortex coming in. Sure.
Oh, good.
Well, and then one interesting thing we were talking earlier about the sun, the current going into the sun. It's like, what are we really, it's not clear to me what we're really seeing when we look at the sun. My guess would be is we're seeing what would be on the Earth would be called the upper ionosphere. And like in the Earth, the currents come into the upper ionosphere. They don't come down to the surface of the Earth except in storm events. Most of it comes into the ionosphere, flows through the ionosphere, and ends up rejoining the, quote, solar wind.
Yeah.
So the surface, what is the surface of the sun? I haven't really seen haven't seen anything good about whether they even know like the ionosphere of the sun, and then is there another double layer under that, and then what is the actual surface?
Well,
Okay.
I watched Sky Scholar. At his first episode discussed, if I'm not mistaken, some evidence showing the splashes of material that land on the sun and then move away in a ring, basically as if they hit a liquid. This would only happen if there's actually a physical surface. So it implies, of course, that there is actually a physical surface. They just don't want to admit this, because how do you have a surface of hydrogen, you know? And this is where he gets into his LHC model, the liquid hydrogen model or whatever. I'm not
How
really...
do you know it's not electrical? I mean, something falls toward the sun, then it's going to take on positive charge, then it's going to be repelled by the sun. So,
well, it's not just that. Also, there's if you look at the sun in iron, so to speak, you can see what would be considered mountain ranges, and they go with the original rotation of the sun. And it seems to be where material is, like the peaks of mountains are where things are happening sometimes on Earth, where you get charges build up. Well, this is sort of happening on the sun as well, because it's not a perfect sphere, and these mountainous areas on the sun might be also picked up, just like in that prominence, and dropped off beside itself, as you see this material as it's flying through the sky, so to speak.
Are these stable mountains?
Semi-stable, just like the Badlands, I assume, in up near where Lilly lives in Oregon, that there have been, they sort of melt and move as they cross the surface, but they're mostly stable. This is, of course, no one wants to really admit this. You have to see this for yourself, because it's no one's going to admit, no astronomer is going to admit. But you're not wrong, by the way, when you were talking about the nature of the ionosphere of the Earth, where electrical forces will impinge upon the ionosphere, and that would be the upper tuft of the sun, just below some of this action here, and it would be the corona. Then would be like our thermosphere. So the circuit is very similar. And I think that it's similar probably because of, like we talked about before, the homopolar motor effect. It just works on the same basic principles of a homopolar motor, but in sphere form, which creates its own secondary currents and tons of other interesting phenomenon. So.
Yes, well, there's a few ideas, unfortunately, even in the EU, that are still wrong about the current flow, and that you get that bigger picture when you see how the sun fits into, like, the interstellar streams and what stars are also in that. But the whole idea is the sun is not an endpoint for current.
It's a load. That's all it is. It's a inductive and resistive load on the circuit. That's
yeah. You have to have current flowing through it.
And
all the evidence. Otherwise the sun would run down over time, or the current flow would have to change over time as it becomes more positively or negatively charged. But we do see a lag in the solar cycle in the southern hemisphere compared to the north. And what I'll argue is that that's exactly what, if the sun has any capacitance at all, that's a simple way to put it. We should be getting current, but it's not continuous current. There's current flows in, builds up, discharges, and that's what we're seeing over time. And that's why the lag of we know we're headed towards, from astronomical even measurements, we're headed towards the north ecliptic pole. That's even illustrated by, like Michael Claridge had that picture, and I think Don Scott too, and that other guy on the internet that showed the solar system moving like a vortex. I don't know how they figured it.
I've seen that too. Yeah.
DJ Seydoux.
Yeah, he's got the.
That was Jim. Jim did that.
Yeah. There's a few people that are really surprisingly into some details. There's a couple that have been, since maybe 2010, have been working on just the circuitry alone of, like interstellar clouds, how the charge is flowing, and but yeah, they've really got a lot of this, the details that unfortunately, even guys like Wal and Don Scott haven't been, obviously they don't spend a lot of time in the forums.
No.
And they're presenting their own material, not even following up all the tangents. But there are some amazingly good ideas in Thunderbolt's forum, as well as all the trolls. And unfortunately, you have to wade through a lot of.
Well, you can do that for us and pick out the good guys, and they can come hang out. But but still, it would be really nice to have some. And you're right, the insights that you've provided to me, and Edwin and Richard, are basically stepping stones, and there's no sense repeating a lot of this work. I've been talking to several people about the circuitry of the sun, and I'm trying to give what I can learn by myself on this subject. And you're absolutely right. I would love to have other people whom are more versed in some of this than even I. That would be, I mean, you don't learn from talking to dumber people. You know, you want to talk to smarter people. So.
Speaking of these currents, I have a question about them. Do we think that there's any thermal emissions in any of the layers or layer separations? Like, for example, if the current is stronger from the northern pole coming into the sun, or if they flip, is one slightly colder than the other one, and one slightly warmer? Because I'm trying to understand this continual dichotomy of the dielectrics forming these concretions that are stars. And from what I understand, one pole always has to be stronger than the other, and that's what creates the dynamic. And that's why they twist and have to reverse their polarity. So do you think there's temperature difference in these
Isn't there, Jim, when you see, you know, something like, you know, obviously you see glow mode happen, but the temperatures that they measure are high, right?
Well, there is an issue with that because electricity, when it begins to influence the flow of objects, actually reduces their heat, because heat is random collisions. Basically, the thermosphere is hot above the Earth because it's an area of neutrality in a way where they can start smacking into each other. The same with the corona of the sun. It's very hot because it's actually where things are pulled past each other. Like you have electrons going one way and ions going the other, and they're allowed to bounce off of each other at these particular points. But once they hit certain areas, they become very influenced by the electric field again, and the heat is gone because it's all put into straight linear motion where they're pulled along. So the randomness, they start spinning in the electric field and magnetic field, basically, is what I'm saying. So it might be counterintuitive because you can't use heat to determine energy.
Right. I mean, that was one of the things I think that balance is really interesting. You know? Yeah.
Well, it's an expression. Like for example, heat and light from the sun is a load on a circuit. It's just like a light bulb. You turn it on. The current, you don't see the electricity flowing, but it's making the heat. It's you know what I mean. But it's only doing that because there's resistance in there, because there's something to push through, and this makes it glow. And this is the same sort of principles that we're referring to with the corona. If I might be correct, Jim or Richard might have more to say on that.
Jim, there was one thing where you're talking about dropping of temperature when a current is going through.
Yeah, well, obviously it's just called dethermalization, like in an electric field, because it takes away the random motion. But one of the interesting ideas to contemplate is that since temperature is the random motion of molecules, if you have like we talk about minimum energy configuration filaments, minimum energy configuration means everything is following along, electromagnetic field lines. In other words, there's no random motion. In other words, in an ideal Birkeland current, there should be no random motion, no temperature And I think that's going to be the key to understanding how superconductors work, is that.
Is it just because the charge propagation through it is so good at charge distribution and efficient charge distribution that the heat doesn't exist anymore, or does it get wrapped up and bound somehow?
Well, see, like what I think is that, like, you know how superconductors have a temperature at which they work at. What if you can drop the temperature to where that random motion is so small that the only motion that matters then is the motion along the electric field direction. In other words, you can only have a minimum energy configuration filament up to a certain temperature. Like, if you look at like what Don Scott's modeling, he's modeling a superconductor. Really, when he says minimum energy configuration, that's everything following along according to. There should be no interaction with charge, no random motion. Everything should be following along the electromagnetic field lines. So that would be a superconductor. But obviously, he's ignoring temperature. He's not saying that things are moving around randomly.
Oh, we're also ignoring synchrotron radiation, because, I mean, we detect with radio waves or with light, in some cases, these Birkeland currents that we can see in these nebulae, for example, nebula or whatever. But that we're seeing it only because there's a load on the circuit. That means that it's actually not as efficient as it could be. When it starts getting into dark mode, really dark mode, and there's no glow mode, because basically the amperage per cubic meter will give you your glow, basically. Well, is it going for radio waves, and it will go to X-rays and to gamma rays or whatever, pass through light on the way.
So the more efficient the distribution, the darker it is.
Yes.
Right?
Until it's, and you know, so if you have a wide current with low pressure, like there's nothing to hold, like nothing trying to work on it to make it confine itself, then it's going to spread out like we see from the sun. It spreads out, and then we don't see it anymore. It just disappears. You know, like, it's still there. I mean, completely there. But go on.
Well, the thing is I can't say exactly what's rubbing against what, but if something's in glow mode, that means it's hotter, and it's creating thermal radiation.
Well, no, it's actually synchrotron. It's not thermal. There's a significant difference. It's like using it like a microwave oven.
Well,
it's not making heat.
And when a lightning bolt comes down, it's hot. I mean, and when the currents come when the currents come into the ionosphere, it creates very high temperatures. I mean, there's collisions of particles going on.
There's no heat in bioluminescence.
But
so what? That has nothing to do with glow mode Birkeland currents.
Well, I was thinking about that. I didn't know if it. You know, I'm just positing. You know that.
It's possible to produce light without heat, but the point is that heat is generated in the corona of the sun and in the ionosphere of the Earth and in glow mode Birkeland currents. I mean, if you're introducing a lot of energy into a system, then heat is going to be one of the outcomes.
Well, I got a good question. If Birkeland currents exist, then we should be able to find the leaders to all circuitry, as far as electricity and lightning. There's leaders, so there should be leaders for the Birkeland currents too, some sort of a leader. And what would a leader look like? Like a leader would be the first current, the current that all other currents spawn off of, and as far as in lightning, there's leaders. Neil, you want to pick it up and explain it a little more?
Oh, I think you're confusing step leaders with circuits. There's
current work like that.
Well, only when it started. I mean, if we got to the main current of the universe, is what you'd have to really go to.
Well, it's continual, so it should It should be going right now, but we don't know. I don't know. I wouldn't know where to look. You know.
Well, the biggest image I've seen is what they call a Nyakai or something. It's the local galaxy cluster.
Yeah.
And so there you can see there's a current coming in, and there's a discharge that looks very much like a cometary discharge.
I noticed that.
So, but it's in terms of our lifetimes or a mere billion years. We could say it's continuous, but it's just a discharge event. Maybe like 1 second on somebody's clock.
But to answer your question, Richard, and I think that maybe Jim could even cast better example on this, but it's basically trying to recognize that there are. Thermal radiation is obviously a real thing. That's basically caused by random collisions, and then you have synchrotron radiation, which is caused.
Well, why do you say random collisions? If you have, in the case of the current coming into the ionosphere,
right?
It's a classic example of a collision with a cathode, and it's very non-random. Protons and electrons running into the ionosphere. It's not random. It's like a fire hose of impacts, and that causes heat. I don't know where this idea that it has to be random came from.
Well, once it gets into near to our atmosphere and stuff, there is definitely heat. Because it's you can see it in the aurora, which actually has starts pinching down, and then you have things impinging on it. Lightning, of course, as you're well aware, it does definitely have heat, but the actual energy level that it's emitting is like gamma rays. It's quite potent in that respect. But
and it's also visible. And
oh, sure, and there's
the whole spectrum.
Well, the explosion basically going along that whole strip because it's exploding the air outwards and so forth. But there are certain places, and I don't want to be completely wrong here, so please help me, Jim, if you can. Basically, that there's a place where your synchrotron radiation will be visible, and there's places where where there's a balance point where the forces are no longer holding as much energy onto it. See that cathode ray right in the middle of the screen, the tube. You're going to have places where there's glows, and then you're going to have places where there is heat being generated. That's it. There's different spots where you're going to have different things happening. Is what I mean.
So let me get this from what I understand. Synchrotron radiation is, it's toroidal, correct? Toroidal.
More or less, basically, you have like in a microwave oven, it's creating a particular frequency in that particular case, but it's created by the spinning of a magnetic field with a certain current and a certain current density, and that's what's going to make this solenoid or whatever it is make the synchrotron radiation at this particular frequency. Now we could turn it and use fluorescence and make light, or we can turn it another way and cause lightning bolts, or gamma rays or whatever, and make X-ray machines. But it's a specific thing. We can actually replicate it. Now thermal is basically caused by heating something up, causing a resistive load, and causing random collisions. And they're just different types of energy expression. So I don't want to be. I'm not trying to say that it's just a misconception. I think not necessarily a problem. It's something that's hard to wrap your head around necessarily. There it is. See, something spinning along the magnetic. They call it magnetic field lines, and then it emits an X-ray. So,
but see, that's what doesn't exist in a minimum energy configuration. When charge is following the magnetic field line, you don't get synchrotron radiation, and that's one of the interesting things that happens in that's why that Bessel function filament idea is so important, is because that gives a way for charge to travel without giving us synchrotron radiation, because that's one of the mainstream arguments against why there can't be all these currents in space. Is if we had charge flowing along the background magnetic field, it better do that,
Yeah, we would be able to see it, they say.
Right.
Well, they marry each other. The idea of synchrotron radiation and the Bessel field line current of Donald Scott's marry each other, if I'm not mistaken, because he was talking about the toroidal fields and how it actually, how when it's pinched, when the current's pinched, how it actually creates the synchrotron radiation. As far as I understand, it's torality all the way up and all the way down, which is what breeds helicity. As you can see, it's nothing but, you can vision a donut moving all the way down that current, and that's helicity. The donut moving is helicity. And the donut moving and glowing is synchrotron radiation.
Well, it's flinging off the vibration of that thing spinning. Basically, is creating frequencies of photons. Yeah.
Yeah, that's why you get glow mode. So that complements what you were saying, right, Richard? I mean,
yeah. I wanted.
Go ahead.
Okay. Well, it's just getting back to what Jim was saying about, a minimum configuration current and all that. The thing is, if there's a current going, there's going to be positive ions forced in one direction and electrons forced in the other direction. And the more intense that gets, the more there's going to be heat from that. So just because it's force-free doesn't mean there's not heat generated.
No, if it's really a force-free, like an ideal minimum energy configuration filament should be completely undetectable. There'd be no way it wouldn't generate any heat because there would be no resistance from it. There would be no collisions between. There could be no recombination if you have the electrons all in, like, say, one shell going one way and protons in another shell.
No, but that's not how it works. It's protons and electrons always in the same shell. It's just the direction of the current alternates as you go from shell to shell. But within a shell, a current is a potential which pushes positive ions in one direction, electrons in the other. They're not in separate shells.
But they in an ideal minimum energy configuration, that's how you get a dark mode. Dark mode means there's no interaction between the opposite charges. That's basically how you can see current at all. Is either by the radiation given off, or by collisions between recombination and ionization, or which gives off light, or in a minimum energy configuration filament, though, in an ideal one, it should be absolutely invisible. In other words, like what you see with sunspots. What's going on through the center of the sunspot is where most of the current is actually flowing. It looks like, not only does it look like nothing, but you can see right through it. We can see through across where that current must be running, right through to the other side of the sunspot, and there's nothing. It really does look like an empty hole, but there's a huge amount of charged particles flowing through there. You just can't see them. You can't.
Would that be the highest? Would it be the highest density though?
Yes, it's actually the highest density.
But it's the most coherent though.
Yeah, it's right. There's no what.
I think maybe there's a confusion on because like, for example, on the sun there is heat coming off of you could feel the energy, but that's of different wavelengths coming off the sun because of its arcing like crazy. But that's actually synchrotron radiation that is hitting us and creating thermal radiation. That's maybe there's a confusion there. I just think this is a minor thing of just not recognizing this little, and trust me, electricity's really messed up.
I don't think it's minor though, because we're talking about how we're observing something, and it's like if you're going to say that the most dense current is right at where you can't see it at all, that's pretty significant.
Yeah, see, when you see that sunspot shape, what you're seeing is almost a toroid. You can, if you'd see an animated one of these, what you would see is what looks like almost toroidal motion. That's secondary currents that are, based on what's flowing through the center. But what's flowing through the center is, effectively invisible, and you're not. That's the whole bizarre thing about a minimum energy configuration shouldn't just. It doesn't even just blend into the background. It absolutely disappears. It's why the mainstream sees like these dark matter strings or
gravitational lensing.
Yeah, it's there. That's the only way you see it. But you don't see the actual current. You aren't going to see a minimum energy configuration current. You might see the charged double layers. That's where the dark matter string comes in. It does. You have that those charged double layers which refract light, but the current itself, it's actually amazing what happens. If you think of all the ways we see charge in space, you don't get those in a minimum energy configuration. You don't get collisions between different charge species. You don't get.
That actually is very counterintuitive because
exactly.
Because as electricity, as someone who does electrical engineering, you know that if there's current going through it, I could if I know all the factors, including what material it is, I can pretty much determine just by the temperature how much current's going through a wire. So it's a really fine thing to think that it can make something very on this low. But we know dark mode plasma exists. I mean, we know it's there, but usually we're doing it in some sort of laboratory experiment under controlled conditions. We don't think about it, in this way that you're describing. In addition, the double layer along the edge of the sun concentrates this effect, but sunspots appear to be where this falls apart.
Well, how do we know that there's current in the dark part of the sunspot?
Wouldn't that be the coronal hole stream where you have a higher photon bombardment?
I remember Don Scott talking about this, but I probably leave it to Jim to describe.
That's what happens. You pick a booger and it runs.
Yeah, you're right. I was thinking, yeah. I mean, the measurement of that. How would you do that? I mean, I see the model, but it's like, how would you verify that empirically?
Well, from my understanding, and I might not be doing it justice, you can see there's like a pathway coming from. They measured sort of like a pathway coming from these holes. The double layer is sort of everywhere it's orange, right on this surface. But where this is collapsing, there's no double layer to hold these two forces, like the ionosphere, holding them at bay anymore. And current is just flowing out basically from the surface of the sun straight on out and is propelled, just shot out there. And it's going quite fast, magnitudes faster than the regular solar wind, from my understanding. And I would leave that to someone else who might know better.
That's what
I was really asking Jim. I mean, Jim is the one.
Yeah, he's not there. I don't think so.
That's the biggest current right there, and I just how do we know there's a current there?
There's definitely a current in the center. You can see it either coming out or going in. You got the umbra and the penumbra. They're forcefully going inward. They're with helicity, you can see there's almost like a spiral to it as well as they go in.
Oh, they definitely spiral. But
No,
Jim,
I mean the visible, there's the visible currents around the spot. I can see obviously they're going in, but the actual the umbra itself,
right?
Jim is claiming is where the biggest current is, and I'm just what is the evidence for that?
Right. Well, it'd be hard.
Yeah, it's always the way, like, you don't see, like, if you look at here on Earth, I mean, pretty much like what Don Scott was showing in hurricanes where there was actually evidence of even counter rotation.
Right.
You see that, but obviously that means current flowing through the center of that storm, up and down through the atmosphere. But you don't see that. I mean, that's not.
It's wild. With a hurricane, it's that's stillness right in the center. You know.
Right.
That'd be like the eye of the hurricane, right? Where there's not wind.
It's just stillness. I mean, it's amazing.
No, there is a pillar. It's actually a pillar, but the pillar is stillness, but it also has sheaths, and it's layered. It's a very long pillar, but in the center of the pillar, it could be still or silent or lacking.
I mean, it goes down as far as the material goes. The movement of the material, it could be there could be amazing things going on there, but the material itself goes to calmness, which is interesting.
I see concentric circles. If you were to draw concentric circles right to the center of the umbra, I would see that to be probably what's going on in the center there. A long column that's like a Birkeland current itself.
Well, it probably is.
You can see this.
Yeah.
Well, I'd say each one of those little yellow dots is a Birkeland current. Is what do they call it?
A filament.
The lightning mode.
Spicules.
The spicules.
Yeah.
So you're not wrong. I think they definitely have a cohesion to them.
And you can see how they're attached. One umbra is usually attached to another umbra, and they move together. And there's a half toroidal field, so it would operate like a Ouroboros, just like when you put the in the pool when that lady put the frisbee and you saw the two umbras moving together at the top of the pool. They work like that, I would assume, where there's both are feeding and excreting each other. We went through it before. If David, I don't know if you could pull it in, because then we could wrap our mind around kind of the imagery. Yeah, the vortical movements.
Yeah, I'll just go direct.
But I don't know if any. I mean, the evidence for that, like I said, I've heard I've only heard basically third hand, so I don't know if Jim has any exact evidence or citations.
For the
just that's where the most dense currents exist at the sunspot.
Well, it's not dense. No, it's the volume. I think it sort of spreads out.
Current density.
Well, no, just current. See, density is why, like, the reason it's so messed up to think about it this way. But basically, yeah, when density gets in there, you're going to start seeing it. That's where synchrotron radiations happen. But it seems that these sunspots sort of create this opening, this hole where and of course it expands outward from the sun and creates sort of like a swath as the sun is spinning, and it's sort of shooting out, but you can't see it unless you're in it, so to speak, and that's why we feel it when we get hit by this.
Velocity of it?
There actually is a velocity change, if I'm not mistaken. They come out a lot quicker because of the fact that they're being repelled directly from the sun. There's no double layer to hold them back. They don't have a thermal radiation layer to hit, where incoming and outgoing are hitting each other, creating that corona. It's not there. It's just going right on through.
I'd really like to understand the sun better. I mean, it's like the first thing you got to recognize is the sun is negatively charged. Like all planets and heavenly bodies, at least according to Wal's model. And if it weren't negative, it has to be negatively charged, otherwise there wouldn't be these currents coming in at the top and the bottom. And yet we think of it as an anode. Well, that's because at some point, in its outer atmosphere, it's more positive than the outer ionosphere of the sun is more positive than the outer ionosphere of each of the planets as you go out.
Correct. That's hard for people to get around.
The bodies themselves are all negative.
That would be my interpretation, yeah.
And so I haven't seen any chart anywhere that shows where the negative part starts, where the double layers stop. I mean, somebody said something about the Iron Mountains, that's a beginning. I never heard of that before, and that's a beginning of understanding that architecture.
Well, there's if we look at every ball being just a metal ball, so it doesn't matter the size, and this is where the original thing that Jim was talking about with regards to gravity was very interesting to me, because I think of things electrically most of the time, not and it can be a blind spot, clearly, with regards to gravity. But not that I'm not wise enough to realize it exists. But it doesn't matter the size of the ball. If it has current going through it, in my interpretation,
Terrence, huh?
Is that real?
Okay.
Hello.
Hey,
Terrence.
Wow. No, why can't I speaker off? Let me turn the speaker on.
Okay. Can you hear
Hello.
me? Hi. All right. Let's see if I can share my screen now again.
I can see it. I see your screen.
Okay, good. Yeah, we're talking about the sun and sunspots and the idea that there's high density of flow right at the sunspot, at the dark spot.
Mine's locked up, so I'm going to actually grab your screen. I'm going to take it from you. No, it's not working.
Oh.
So
Okay.
there. Now I stole your screen. Now steal it back from me.
Okay.
And it should be fine.
I know that most of our conversation has been dominated about the sunspots, but I feel like we're missing part of the conversation in regards to the coronal hole stream and how coronal hole streams actually have a higher photon bombardment than what the sunspot active regions do.
Well, there's obviously if I'm not mistaken, there are large streams coming out of the north and south pole of the sun. Well, I said coming out, but obviously in my interpretation, they'd be going in. But
Yes. They're going in the north and the south. The only thing escaping the sun happens at its equator.
we were just talking about that. The solar outflow, yeah, right along the within 30 and plus 30, negative 30, yeah.
Mm-hmm.
That's where you start seeing. I mean, you see the densities of the activity along these lines. This is where we start getting back into our geometry ideas, you know.
And that's where the friction is occurring. You know, where you have an influx, an in-stream of highly toxic charged particles returning into the sun from the heliosphere, and right at that edge right there, where you have the centrifugal force taking place, centrifugal flow interacting with the centripetal flow, and that's where all the sunspots ends up really occurring.
Mm-hmm.
Well, and we were just talking how that's the same on the Earth. We have a point on the plus 30 and negative 30 where you get the tornado alley and thunderstorm alley and that sort of thing.
And it's a star tetrahedron, ultimately a spinning star tetrahedron.
Right. Doesn't that one come up a lot? Yeah.
And if A is equal to B and B is equal to C, then A is equal to C. And that's what science keeps forgetting. You know, the universe does not change its laws or its patterns for any reason.
I mentioned earlier that there was currents coming in the poles of the Earth and going out, and someone corrected me and said that they were only either going in or coming out, but I would argue and say that they're doing both.
Well, the maps I've seen of the Earth currents always show a current coming down and then skirting along the surface of the ionosphere and then going out again. And I've always wondered, I mean, is that true?
That's
On
Michael
the planet,
Claridge,
on
if I'm
Earth?
not mistaken.
What?
On Earth?
Or those could be the two cylinders of vertical current which go in opposite directions, I suppose.
Right. So
It
you're
has to be
saying... Sorry. I want to clarify. Richard, you're saying that the current's going through it?
Well, I mean, there's a current coming into the ionosphere. Now, when you see counter-rotation in the aurora, then you're seeing two different cylinders, and they're going alternate directions. So the cylinders rotating the other way from the central one would be a current going upward.
Well,
Yep.
it's going upward, but it's
out.
going upward in an attempt to plane itself out as the centrifugal force is pushing it more so outward because it's being multiplied by a ratio of 6 in comparison to the ratio by which it is coming in. The collapsing vortice is coming in at a ratio of 5. So there's always going to be the friction of them passing by each other. But because of the plane that's being created, anything that's discharging always will discharge from its equator. Otherwise, the entire system would break down. And I believe you are correct, buddy, that everything, as it's taking in, it's also discharging. That's just
it has to be.
That's the balance that keeps this clock going. That keeps this spring wound and unwound at the same time.
Yeah.
Yeah, but the thing is, we've also said earlier that
Go ahead, Richard.
the central current, which is the main current, primarily goes out more at the equator.
Correct. That's where you get your Van Allen belts and such.
So if that's the primary flow, then this business of there being an upward flow near the pole is really a secondary phenomenon. That's just the property of a Birkeland current.
But it never is allowed to escape, I believe. I don't believe it's ever allowed to escape from the north because of that influx, and it keeps getting pushed further and further and further along the edge of the earth or the planet or the structure until it gets to a place where it's allowed to go out, and it comes out with so much force because it kept getting knocked back down because of the influx that was happening. As per Walter Russell, as per John Keeling.
I think a lot of us are forgetting that we are actually part of this charge distribution. So this charge, these Birkeland currents that are coming into the Earth are actually going and propagating outward from the equator and propagating into living systems. I was talking about the hydroelectromycelial circuitry, and I think that there's really something to be said about how lightning communicates to all of creation, and through the mycelial networks, the effective types of, for lack of a better term, information. It's like lightning is almost like the harbinger or the bearer of highly articulated and formatted informative information, which accretes into chemical bonds, which create phosphorus for the roots to grow, and it's distributed throughout the landmass, and there's also it works through the clouds. There's communication in the clouds, and it thinks a lot about where it's going to do its next lightning strike, and it feels it. It's a feeling and sensation type of thing, And I know this is talking more like Gaia and turning the Earth all alive, but I feel like there's a brain in the clouds, and then it distributes it carefully across the landmass, and the majority of the lightning is actually distributed on the land. But anyway, that's just
I'm gonna write that quote down. There's a brain in the clouds. I like that. But I think back what Richard was saying is you might be right about the secondary effect idea, because there is definitely the currents in the poles out along the elliptic. I think that might be where Jim is basically right in the idea of these concentric circles and being basically stable orbital places or along the current sheet. But then there is this solar wind that's going by. And then it has to be those electrons and those protons have to be processed as well. So they get funneled into the magnetic field that's being generated, and then they pass out on the night side, so to speak, along the tail of the Earth, the plasma tail or electromagnetic tail of the Earth. And that then they flow along that until finally they have grounded out along and continue along the solar wind out past Mars, I guess.
Well, Dave and I were talking on Saturday, and one of the things that came up is that it's like a whirlpool. The vortex coming into the Earth, you could think of it as kind of like a whirlpool in a river.
Right.
Oh yeah, and you should see the one on Venus. Like you could actually see the footprint, like the two currents twisting around each other like a galaxy almost.
Yeah.
On the poles of Venus.
You think of the Earth. You think of a body like the Earth is like a drain in a sink. It's a drain on the current coming from the sun, and so it swirls down into the drain and then goes out over the equator.
And then there's the pull again, as it's kind of this is where you kind of see the recursion quite a bit as you go down in. You see it. Here's the big one, and then within it, you start getting these harmonic relationships.
It's boggling my mind, all this.
I know, eh? I'm just sitting there just...
What's the South Pole look like?
With that big landmass there.
Yeah.
I like how you can tell the general flow. It's like clearly, like going that way, the right-hand rule. I mean, just with that alone, you can tell how much current is going through, probably, if you thought about it.
Now, land is, I guess, more of a resistor compared to saltwater, which would say that it would be easier for currents to make their way into the Earth system in the north than in the south.
I think that.
Well, I would.
Oh, go ahead. Sorry, Terrence.
If I may, I would beg to differ a bit on that opinion, because remember, electricity always seeks it accumulates mass together, and therefore the accumulation of mass allows the electric current to pass through it. Now, what sodium does to the water is allow for an accumulation of mass, or a symbol of mass that it can flow upon, and that's how that ends up occurring. But I think electricity passes over mass with a greater rate and more attracted to it than it would even with the salt water as a whole.
If I was a betting man,
I was actually researching this this week. Sorry to interrupt, Neil.
No, that's fine.
Because I've been very interested in this topic, and the majority of lightning strikes do happen on the landmass because heat. It has to do with heat and cold, of course, thermal, and it's easier to heat up the Earth's surface than it is to heat up the ocean's surface. So therefore, the majority of them happen on landmass.
I would always think that it would have to do with the fact that that it's flat, basically.
It's not flat, Neil.
No. I meant that the ocean is relatively the lowest point. Is what I meant. Sorry, not flat. No one get any ideas. But you're probably not wrong with regards to the best place to make the connection would be the dirty water along the edges of the continents. This would be the best spot because you'd have the mixture, basically a lot of dirty water with lots of charge carriers in it. This might, as we've talked about before, might be why there is a ring of fire where the entire ocean currents sort of have to ground out along the shorelines or ground out at like Mount Kilauea that's going off right now. But, this is speculation, but this is where we start going into, because clearly really muddy water is pretty conductive. So,
well, let's talk about these circuits and how they extend heavenward and go all the way out to the sun. And what are the names of these? I mean, we have names of them: sprites, elves. I mean, what's beyond that? Are we going to name some of these that extend further? And are they unnamed? Are they named?
I think we used to call them dragons.